Hello friends, this is Durga from IT University. As part of today's topic, we'll be covering data warehousing concepts. I have started as part of the previous session. We'll continue talking about data warehousing concepts. Those who are joining via YouTube for the first time, this is for the ongoing batch called as Data Engineering Bootcamp for those who are graduating this summer from US universities. This is a guided program where I'll be conducting live sessions. If you are interested to be part of this series, you just subscribe to our channel and click on notification icon. Whenever I publish the session, you will get the notification. Either you can join live or you can actually watch the pre-recorded video. That being said, let me actually open the PowerPoint and then I will walk through the details that are covered so far, and I'll continue covering the details with respect to data warehousing concepts. Let me open the PowerPoint here. Okay. So as part of yesterday's topic, we primarily focused on facts, dimensions, measures, hierarchy, granularity, etc., using our retail DB use case. And I hope most of you who actually watched the yesterday's session are clear about these concepts. There might be some gaps, but at least you are familiar with the terms now, and you should be able to pick up by reviewing multiple data models. That being said, we have already seen that the retail DB is a database supporting a simulated e-commerce platform, which is a transactional mission critical application which is serving sales of a e-commerce platform. And from that, we want to generate reports. And we have gone to the concepts. So we have done a prototype using Tableau by connecting to the database directly and generate reports and dashboards off of it. Even though it is possible to do so, there are certain restrictions or limitations where we might run into serious issues. To address those issues, we typically have a downstream database or data lake using big data tools, and then we get the data from source into the target and generate reports off of it. However, we will not be creating tables as is. We have as part of our transactional system, our database supporting the transactional system. Instead, we use something called as dimensional modeling for performance reasons. That's where, based on the report requirements, we need to identify facts, dimensions, measures, hierarchy, granularity, etc. And we have to build tables based on that information. And then we have to get the data from source into the target. And that process of getting data from tables which are created using normalized or normalization principles into the tables which are designed using dimensional modeling principles is called as ETL. We extract the data from the source systems. We apply required transformations to port the data into these facts and dimensions, and we typically load the pre-processed data into these facts and dimensions, and then off of it we typically run the reports. That's what is covered till yesterday. We'll continue talking about some other some additional details, and then we'll actually revisit the high-level components with respect to a data warehouse, which are nothing but operational data stores, data marts, enterprise data warehouse. I will cover the concepts behind it, and then I will continue discussing about how a typical legacy approach based EW is created. Even today, this approach is used for small to mid-sized businesses. There are so many companies which are still using the legacy architecture, but with enterprises where they have huge amounts of data from multiple sources, big data ecosystem is a prominent one, and I will walk you through the architecture about how we set up enterprise data warehouse to get data from multiple sources, and how we serve the downstream applications. I will be covering as well. And then I will talk about building the data pipeline. What are the skills that are required to build the data pipeline? And then we will talk about development environment at a high level. Then we'll actually talk about the requirements. These requirements are copied from the Google Doc. And after today's session, I will share this PowerPoint as part of our Slack channel so that you will have it for your reference. Then we will actually come up with facts and dimensions. I will give you the details about facts and dimensions using this information. Using Postgres as the database, we want to first create the tables, and then we have to pick up some key skills with respect to Python, and then we have to come up with a design and implementation of the pipeline where we read the data from a MySQL database and then load the data, process using pandas as the framework, which is Python-based library. Using pandas library, once we process the data, we want to write the data into the Postgres data warehouse, a data warehouse which is built on top of Postgres. A data warehouse is nothing but a set of tables which are modeled based upon our dimensional modeling principles. So I will walk you through these steps today, and then those who are comfortable with Python, you have to quickly revisit the Python skills, go to JDBC programming and pandas for next 4 or 5 days or 1 week. You can focus on acquiring the skills, and also you make sure that the environment is set up as I have suggested here. I will guide you through about the development environment setup process, and I will also help you how to set up a project and integrate with GitHub for versioning of your code. So you have to start versioning the code from day one. We'll start with something called a starter kit, and then we'll use it as baseline, and we'll start pushing the code into the GitHub. And within next 2 weeks, you should be able to complete this pipeline. And I will guide you through the whole process. And again, it is self-driven. You have to pick the key skills that are required to solve the problem, or to build the data pipeline. And in case if you are stuck somewhere, I'll be there to support, and we can support each other mutually as well. That being said, now let's go back to this. Till yesterday, I have spoken about, as part of yesterday's session, I have spoken about facts, dimensions, measures, hierarchy, granularity, etc. I have covered some of these aspects also, like facts will contain dimension keys and measures. For example, when it comes to daily product revenue, the dimension keys are nothing but date ID and probably product ID. Those are dimension keys. For revenue, the measure is nothing but revenue itself, and the field that can be used to compute the revenue is nothing but order item subtotal. Okay, so facts will contain dimension keys and measures. Measures is nothing but numerical fields which are typically created by using aggregate functions on a particular field. Dimensions contain dimension attributes. Those dimension attributes are nothing but labels for our reports and filtering criteria. For example, if I open my Tableau public, and if I go to the report and dashboard once again, I will quickly recap where these dimension attributes, what these dimension attributes are. And I will just highlight that those dimension attributes are typically stored as part of the dimension tables. On top of labels, we also use these dimension related values that are stored as part of the dimension tables for filtering as well. So let me open this dashboard real quick. You can see here, this is a dashboard with 2 simple reports. One is monthly revenue and second one is daily revenue. And I have applied filter criteria only for closed and complete. So this is one dimension, or dimension attribute. It's not a dimension, but a dimension attribute where I can consider whatever statuses I want to compute the revenue. And then when it comes to the default dashboard, we got monthly revenue starting from August 1st till May 31st, or I think June 30th. Yeah, this is from August 1st to June 30, 2014. This is monthly revenue, and this is daily revenue. Now, if you want to drill down for a given month, let's say this month, and you want to see the details about how the revenue is generated for that month, because there is a spike from October to November. I just want to see whether it is a particular day on which the sales are high. For that, I can click and I should be able to get the details. You can see on November 5th, and around November 23rd, 24th, etc. There are some spikes due to which the revenue is a bit high in November. After that, it is kind of the trend is going down. So the revenue that is being generated is going down, which is not a good sign for a company. Okay. Similarly, if you want to look into the pending payment details rather than uh, uh, closed and complete, I can deselect this closed and complete from here, and I can consider pending payment. However, it is not reflecting here. I think let me see if it is related to pending payment or yeah. So this one is not reflecting automatically when I yeah, now it is so once I select, it is not refreshing for some reason, but once I click on a particular month, okay, this is actually based on complete and closed, I guess. This is not based on the filter criteria that is being selected here. I have to link this so that it only determine the revenue uh, uh, for pending payment in this case. I think this is the total revenue I'm getting. There is a bug in the report or dashboard where the daily revenue is not based on the filter criteria that is selected here, which is a bug and we need to fix it. Anyway, I don't want to get into those details now. I just want to highlight what are those that will be populated as part of the visualization from the dimensions. They are nothing but filtering, the filter criteria which we can choose to refresh our report or dashboard in interactive fashion, and also the labels for our, especially on one axis, for our graphs or charts, whatever we want to use. Okay. Now, with respect to dimensions, there is a concept of slowly changing dimensions. If you go back to our data model, right? Let me pick the data model quickly. For that, I have to go to my document. So when I actually when I start getting into data warehousing concepts, first thing what I have covered is categorizing our transactional tables. It is very important for you to understand categorizing those transaction tables. Categorizing the tables. The tables can be categorized into transactional tables, metadata tables, workflow tables, etc. by looking at the data model. Or you can sit with the architect of the application who designed the e-commerce platforms, and you should be able to identify the categories of tables easily. As part of this simple data model, we have transactional tables and master data tables. Transactional tables are nothing but orders and order items. Typically, facts are sourced from transactional tables, and then dimensions are sourced from the master data tables. And one of the key characteristic with respect to transactional tables versus master data tables is the transactional tables change a lot more frequently compared to the master data tables. As we are designing our dimensions from the master data tables, they change, but they change less frequently. That's where this changing dimension comes into picture. Most of the dimensions are slowly changing dimensions, and depending upon certain criteria, we have to design these slowly changing dimensions. And the way you design is by using type 1, type 2, type 3, etc. So when it comes to designing the dimensions, we need to understand the relevance of change, and then we have to decide. So I don't want to get into too many details at this time, but it is also a very important concept for you to understand the purpose of these slowly changing dimensions. We will come back to this at a later point in time. As this is yet to be covered in detail, I'm just highlighting in yellow. After we complete the pipeline, we will actually discuss about these slowly changing dimensions. For now, I will only touch base about slowly changing dimension type 1. So when it comes to slowly changing dimension type 1, as part of our dimensional tables, they reflect the current snapshot of the source. For example, as I have explained to you yesterday, when it comes to the dimensions in the downstream system, we can have either 3 dimensions, right? We can have either 3 dimensions: products, categories, departments, if we use Snowflake schema. If we use a star schema, we might have only one dimension, and that dimension will contain product ID, product name, probably product description, and then the category name, and probably category description, department name, and department description. So if you follow type 1 approach, whether it is a denormalized dimension or normalized dimension, the type 1 will reflect the current snapshot of the source system. Okay, so we just have to devise a strategy where our dimension is populated to reflect the current snapshot of the source system whenever there is a change in one of the product or one of the category or one of the department. The change in product is more often compared to change in category or department, but still even at department level and category level there might be changes. And if you want to use type 1 dimension, we have to make sure that the snapshot the dimension tables represent this current snapshot of the source system. For now, we will follow that approach, and we will come up with the strategy to get the data from source into the target to reflect the current situation, and we'll take it further. This data model is not good enough in capturing the delta. We will talk about those limitations also once we get into the implementation, and we'll make some changes to the existing tables, and then we will see how we can implement. And also I will give you some tips about how you can produce more data into these tables without putting too much of effort. The data will not be of very good quality, but you should be able to populate these tables with ease. I will give some tips for that also, so that we simulate as if we are getting data on regular basis into these tables, and then we will come up with a pipeline where on daily basis we can capture the data from these tables, apply the transformation rules, and load into our data warehouse. We will come up with a data simulation, then we will actually come up with a code to implement the logic, and then we will even see how to schedule it using Airflow. So that is the complete process which we are going to follow. To focus on the pipeline first, I'm not getting into too many details with respect to slowly changing dimensions at this time. It will be a overkill for you. Just remember that we'll try to maintain the current snapshot of the source in the target system when it comes to our dimension for daily product revenue based report requirements. When it comes to dimensions, there might be hierarchy. I think it should be clear for you. If we actually map to our data model, our product have one hierarchy, product, category, and department. Date always have the hierarchy, and date is used commonly across almost all the data warehouses. We might model our dimensions using star schema and snowflake schema, which I have already covered. Now, when it comes to data warehouse components and methodologies, you need to be familiar with these terms called as operational data stores, data marts. Data marts contain facts and dimensions as per report requirements. All facts and dimensions related to closely knit reports or dashboards are called as subject areas. So in our case, we can say our revenue-based dashboard have two dimensions, which is nothing but date and product. And then we have one fact table. Let's assume that there will be one fact table which contain data pre-aggregated at daily level. So that one fact table which is pre-aggregated at daily level and two dimensions combined together serve as a subject area. Okay, it's a very simplified scenario. In companies, in actual implementations, we might have more than 3 tables, but for now, we will just focus on this 3-table subject area. And data mart might contain multiple subject areas. Data mart is a bit at higher granular level. Within data mart, we might have subject areas. And at department level, we might have data mart. And enterprise data warehouse is nothing but a group of data marts. So for example, let's say you want to generate reports and dashboards for HR, for manufacturing, for IT, for customer engagement, right? So these are all at a much higher level within the organization. We will have data marts for them, like HR, IT, manufacturing, customer engagement, etc. And within each data mart, we'll have subject areas. So for HR department related reports and dashboards, there might be n number of dashboards, and there might be those dashboards might be grouped into subsets, and each subset can be called as subject area. So that's where the concept of subject area comes into picture. And operational data store, I will explain that in a moment. First, let me actually take you through the legacy architecture. It also contains ODS. Then I will actually get into the details about ODS. So when it comes to a enterprise data warehouse, first let us talk about sources. This we have discussed earlier also. So actually this is a continuation for this, right? So earlier we have seen this. So let me revisit this first, and then I will get into the next slide. So we have already seen that for a given organization, there might be multiple sources, and there can be multiple targets like files, databases, big data clusters, external applications, etc. In legacy world, we might not have big data clusters. We might have files, databases, a traditional data warehouse, and external application. And we want to get data data from these sources into these targets. The data might be integrated between these sources and targets either by using batch or real time. So if you want to build an enterprise data warehouse, and if you want to serve these kind of different use cases, so enterprise data warehouse is one of the target here. It need not be the only target. It can there can be multiple targets also outside the scope of enterprise data warehouse. For example, as I have explained to you earlier, right? You might want to build a customer loyalty program, and for customer loyalty program, you just want to capture the customer details and the revenue that is being generated by customer over a period of time, so that we can categorize the customer into a appropriate categories such as gold, platinum, etc. So it is not a complete data warehouse type of application. We just want to build some microservice to communicate with customers based upon their subscription level or loyalty level. And for that, we might want to get the data from source systems and then come up with some data integration framework, get data into databases and take it further. That is not a traditional reporting use case. One of the prominent use case with respect to any organization is to have an enterprise data warehouse and get the data into it, so that we can report off of it. Now we'll try to connect these dots from the enterprise data warehouse perspective. Similar patterns can be observed in non-enterprise data warehouse use case also. When I say enterprise data warehouse, typically the data warehouses are used for reporting purposes. Okay. Now, when it comes to traditional EDW architecture, we will have source. When it comes to target for the EDW, the target is nothing but our report or visualization framework. Ideally, I should have bring up this reporting one, but it will come in a moment. So as part of the EDW or ODS, we will have something called as ODS. ODS stands for Operational Data Store. I will explain the relevance of it in a moment. And then we'll have a data warehouse. Typically, the data has to be integrated into either ODS or data warehouse or both, using some data integration framework or technology. Now, from the sources, data has to come through the data integration framework, because we have to integrate. There has to be someone in the middle who can integrate the data from the sources into these targets. And from this ETL framework, data might go to a data warehouse, but typically we directly push data from these different sources into data warehouse only for prototypes, POCs, etc. In the actual implementation of the project, we get data from these sources, then we push data into the ODS, and then we actually do the ETL and then get the data into the data warehouse. So the full-blown ETL lifecycle will be to get the data from sources using some data integration tool or technology. From there, data will go to ODS, and then we will do the ETL and we will populate the data into the data warehouse. So what is the relevance of this ODS? If you look at this, there are multiple sources from which we want to get the data. And each source system might have different SLAs to retain the data. For example, right, as part of your e-commerce platform, the order management lifecycle might end once the order is closed or completed or cancelled. Okay, once the order is cancelled, after a while it is gone. We don't need to maintain it. So in most of the mission critical applications, once the order is closed or completed or cancelled, or whatever the final stage is, there might be multiple exit strategies for a given order. Whatever, however the order is exited, after a while we want to clean up the data so that our database doesn't grow abnormally over a period of time. So typically most of the source systems will maintain the data up to 2 to 3 years based upon the refund policy, internal compliance, external compliance. In all the based on all these factors, they will maintain the data in the source system itself for 2 to 3 years. Beyond that, they just want to delete the data, and so that the database size is under control over a period of time. Similar to the OLTP system, there might be some other sources also where we want to get the data, and their SLAs might be different. And our report requirement SLAs might be different. And also sometimes for litigations between counterparties, the external bodies enforce the compliance rules for 7 years. For example, you might have heard about Securities Exchange Commission, right? SEC. So all the stock trade data should be maintained. All the financial reports which drive the valuation of the company has to be maintained by the company for 7 years. And SEC will chase that company down if the financial reports are not maintained for 7 years. Not only the reports, but also the data supporting the financial reports has to be made available. So almost up to 7 years, the audit can happen, and the company should be able to provide the data to show how the financial reports are determined. Similar to that, when it comes to our credit card transactions, right? Our credit score also typically maintained for 7 years. So if you made a mistake and if your credit score got impacted, the details has to be stored for 7 years by the your credit score will get impacted almost for 7 years. And to support that, almost all the credit card companies whoever lodged a complaint against your credit report has to maintain the data for 7 years, so that if you file a case against a company, the company has to come back and support why your credit score got impacted. Right? If there are any delinquent payments or delayed payments due to which your credit score is impacted, then the underlying credit card company has to maintain the data for 7 years. So from the external compliance perspective, typically most of the things has to be maintained for 7 years. However, if a highly charged mission critical e-commerce platform or any business have to maintain the data for 7 years, then it will become highly expensive for that company to support the traffic without slowing down. And hence, typically, as part of the OLTP systems, we don't maintain data for 7 years. We typically maintain only for 2 to 3 years, depending upon certain compliance rules. That's where the ODS comes into picture for compliance purposes and also for our report lineage perspective. The data will be maintained in ODS based on our report requirements and also external compliance requirements. And when we actually get the data to ODS, we typically get the data in almost in the same structure as the source tables, or whatever source we are getting from. Using the same structure, we typically maintain the data in ODS. We will not be applying dimensional rules over there. We typically have the tables almost, it's not complete, but almost as if we have the tables in the source. And from there, so we will first get the data quickly from these sources into ODS, where the tables are of the same structure, and hence our ETL or data integration logic to populate these ODS tables will be a bit straightforward. From there, we'll actually take care of the ETL by applying the transformation rules to support our tables modeled based on dimensional modeling. So one, for the compliance perspective, to maintain data for longer than the source system SLAs, we use ODS. That is the first scenario, or that is the first case for the purpose of ODS. And second one, there seems to be a question, and also let me actually add all the attendees to panelists, and then there is a question in Q&A. I will look into that question, and then I will talk about the other scenarios where ODS comes into picture, or ODS comes handy. And also, whenever you try to learn these things, right, you make sure that you understand the the actual meaning of it. Many times, if you start understanding the actual meaning of it, it will start making sense for you. You will be automatically able to build the intuition to understand the bigger picture. Okay, so just focus on the meaning of those terms, and you should be good to go. Now, let me actually take this question, which is part of Q&A, before I go further. So Aditya is asking, ODS is a kind of staging area. Also, what type of storage it is, block level. So I will get into those details. Okay. First, let me explain the scenarios where ODS is relevant. One, to maintain the data based upon the SLAs of our downstream reports. Second one, let's say you build a report or dashboard, and let's say we feel that the report or dashboard is not correct, and the report or dashboard might be built using data sourced from these different sources. There might be one dashboard which is primarily sourced from data from this OLTP system and also closed mainframe system. Now, if you want to troubleshoot that report, you have to go to the sources and you have to start troubleshooting the issue, which is a bit tedious and also very time consuming. And at times you might not even have the actual data that is used for the report as part of the sources, because of the SLAs to maintain the historical data of the source systems might be different from the SLAs of your report requirement. For example, you want to see a report for past 7 years. The actual data that provide you the report for past 7 years might not be available in this source system, and hence the ODS is designed similar to the tables from the source, and we will maintain the data up, as per the SLAs driven by our report requirements. It will not only be easy to go to ODS and troubleshoot the issues, we can also maintain the data as per the as per our data warehouse requirements. Okay, so this is second use of the ODS. The first one is for the compliance perspective. Second one is for the data lineage to troubleshoot the bugs in our reports. Okay, so now to answer the question which is asked as part of the Q&A, how the ODS is typically designed. If you look at this cylinder icon, right? Cylinder icon typically represents RDBMS. Traditionally, ODS is designed using RDBMS itself. It can be Oracle database, it can be MySQL, it can be Postgres, etc. It is primarily used to stage the data. We will not be running heavyweight reports or scheduled reports which are relevant for our businesses off of ODS directly. Typically, all the reports will go to the data warehouse. Because if you go to the ODS again, you might have to join multiple tables, and also the report might take too much of time to show the results. For that reason, we don't report off of ODS that often. Another thing which we typically consider as part of the ODS is, for example, right, as part of the order life cycle, you might place an order which will result in insert, and once you place the order, it might start with a new, and then the processing might start, and then the vendor might have accepted the order. So vendor accepted can be third state in the order lifecycle, and then he might have finished the order and made it ready for the shipping, or ready for the pickup. So finishing the order by vendor is another status. Shipped can be another status, and delivered can be another status, and then closed can be another status. So over a period of order, we might insert the record when the order is placed, but to maintain the status, we might update several times, at least 7 times, based upon the hypothetical life cycle which I have explained. And if we want to support all our reports, sometimes we might want to capture the details about these statuses also. So typically, as part of the ODS, the way we define the tables is even updates on the source systems will be converted to inserts, and we might end up having the insert record and also all the 7 updates that have happened through the life cycle of the order. And using that information, it will be easier for us to take care of the litigations from the compliance perspective. And also, if I want to understand the report, where what is the average duration from new to closed, once the order is placed, how much time it is taking to close the order, right? So we might have to go to the life cycle of the order, and we might want to compute the difference, and we should be able to see where it is taking time, and we can actually try to fix that stage where it is taking time, and we can reduce the average order completion cycle as a business, right? So even to support those kind of reports, and also some compliance requirements also demand that we maintain the track of the transactions, especially with respect to orders and all. With respect to ODS, we might maintain the data up to that level where the source system might only have the current snapshot of the order, but the ODS might have the complete chronological events of that order, which will help us in addressing litigations, and also help us in building some advanced reports. That's why I mentioned that the tables in ODS will be similar to the tables in OLTP. However, they are not same. We will end up having these additional or we'll try to capture these additional details as part of the ODS tables. As part of the data pipeline, ODS is not in scope. Don't worry too much about how to design the pipeline considering ODS. We will directly get the tables from the OLTP system into the data warehouse doing the ETL. However, I will show you a few examples how the ODS tables will look like, and you should be able to pick up the key concepts with respect to ODS. Okay. Because if I have to build ODS going into all those details, simulating that data will be a bit nightmare. However, I can actually explain all the concepts related to ODS at a later point in time. So Likita have a question, but I will take that question in a moment. Let me take this question from Aditya. And also, I actually suggested to use Slack for the questions so that we don't miss the track of these questions, right? Even if I forget to answer, we can follow up as part of the Slack, and we should be able to take it further, right? So let me take these questions, and also let me keep track of these things as part of the Slack. Going forward, please ask the questions in the Slack only. And if I'm not answering those questions due to using multiple tools, you just ping me in Zoom saying that there's a question open in Slack, can you answer? Then I will go to the Slack even if I miss, and I will try to answer. So there is a follow-up question from Aditya. There was a earlier question also. So the question from Aditya is it necessary to use relational DB for ODS? Can we use a flat storage like S3 or Glacier, since it's not used for querying or reporting, just insertions? Good point, Aditya. We can use that, but we are not yet with respect to the big data ecosystem or cloud. I'm still talking about the legacy architecture. Actually, this slide is a bit outdated. That's why it is saying current architecture. I should be replacing to the legacy. Let me do it right away so that it will not cause any confusion going forward. Okay, so as part of the legacy, we don't have cloud option, and at that time, we typically use databases such as Oracle for the ODS. But your point is right. If you want to go with cloud, yes, we can leverage S3 and Glacier. It's a valid idea or valid approach. Many companies does that. And then Likita have a question. Likita's question is, what is the difference between data mart and ODS, as data mart also maintains the data as per the report requirements? So if you follow, ODS is separate. ODS is not part of the data warehouse. ODS acts as the intermediate layer between actual sources and the target to address whatever issues I have highlighted so far. ODS is not part of the data warehouse, and even this picture depicts that ODS is here and the data warehouse is here. Okay. However, at an enterprise level, we use these terms closely, and hence, when we actually talk about enterprise data warehouse components, we even consider ODS as one of the component. Okay, that's so just. Even though these are visualized from the enterprise data warehouse perspective, ODS is not integral part of data warehouse. It acts as source for our data warehouse. As more than source, it acts as the intermediate layer between our sources and the targets to maintain the golden copy of our data. So ODS only have the golden copy of our data. Data marts are part of the data warehouse. So group of data marts for each department. I have explained that earlier also. So there is a report and dashboard. That is the lowest granular level. You will be so at the lowest level you have report. There can be multiple reports, and those reports can be grouped into a dashboard. So each dashboard might have multiple reports. When it comes to tables, you should not be creating a group of tables for each and report or for each dashboard. There can be multiple dashboards which can be developed using closely knit tables. And those closely knit tables is called as subject area. Subject area typically supports multiple dashboards. So report, then at a higher level dashboard. To support multiple dashboards, we create a group of tables, and those group of tables are called as subject areas. Okay, and group of these subject areas is nothing but data mart, and data mart is typically per department basis within an organization. So if you have an organization, there might be departments: HR, finance, and IT, manufacturing, customer engagement, or sales. So you have all these departments, right? So at each department level, we build the data mart. Sometimes we even build cross-department data marts also. Okay, so departments are higher level. Typically, there will be data marts at department level, and there will be cross-department level data marts also. Okay, typically data mart might not. In all the cases, data mart might not be part of one department alone. There can be some cross department data marts also. So that's how you can visualize the relationship between reports, dashboards, subject areas supporting multiple dashboards, and then data marts for each department or cross department data marts. So that's how you should be able to visualize with respect to the key components of data warehouse. ODS is outside the scope of data warehouse typically. It acts as the intermediate layer between our sources and our data warehouse, and it will act as a golden copy of our data. It will store the golden copy of our data. Okay, so that being said, now let me go back to this slide. So once we get the data from source into ODS with minimal transformations, then we actually get the data from ODS into data warehouse using ETL. And when it comes to this data loads from the sources into ODS, it might happen in real time. It might happen in batches. So for real time, we use different set of tools. For batches, we use different set of tools if we follow the legacy architecture, which I will cover at a later point in time. Don't worry about tech stack at this juncture. Now, once the data is in data warehouse, so if you look at this, there is a direct link also from the sources into the data warehouse, right? So there is one link where the data go to ODS, and then from ODS the ETL is being performed. And there is also direct link from the data integration layer into the data warehouse. For prototypes and all, we bypass ODS and we directly get the data from OLTP to data warehouse. We will generate the reports. If the reports are working properly or as expected, then we want to publish those reports as per the SLAs. So we might want to send an email to the executives on regular basis, like hourly or daily, etc. So that's where the actual project will kick in, and you have to then introduce ODS as part of that flow, and then get the ETL done, get the data ported into the data warehouse, then start connecting our visualization tools into it, and start sending the reports. When it comes to our visualization tools, typically the data will be sourced from the data warehouses, but in some cases, especially for ad hoc report requirements, some business analysts might want to go to ODS. They will look at ODS and see if they want to start generating reports based upon certain data elements. First, they will evaluate whether the data is available in ODS or not, and based on that, they will start building the business requirements. And using those business requirements, again, we will go to the actual implementation of the ETL process and the reporting process. So even reporting involves certain level of development. And before going to the complete development process, the business analysts might want to run some ad hoc queries, and they can use ODS. They will see if the data is available in ODS or not, and it will actually drive the complexity of our project. Okay, that's why we have connector between ODS as well as connector between ODS and reporting, and also from data warehouse and reporting. And reporting is typically done for the decision support, where the executives can actually make certain decisions. So there are several limitations with this approach. One is you have three different technologies for three different purposes. You have ODS typically built using technologies like Oracle. The data integration is typically done using traditional ETL tools like Informatica, DataStage, etc. It requires different set of servers or different type of servers. And then you have data warehouse, which is typically built using Teradata, Greenplum, Vertica, etc. Again, they require different type of hardware. So you will end up with heterogeneous hardware, and there will be maintenance issues and all. We will actually reiterate these things at a later point of time also. But from this picture, what you can understand is it can be a maintenance nightmare at one point or the other, and also the companies have to pay huge amounts of money in the form of licensing. Okay, and people want to go for open source alternative. That's where the big data ecosystem comes into picture. There is no change in the source. We typically get the data from sources. But when it comes to the enterprise data warehouse, where we have ODS, EDW, etc., and also we have ETL based layer, everything can be set up as part of the big data cluster itself. When it comes to big data cluster, the storage and the processing are separated. For processing, we use Spark. ETL is typically processing. Creating the tables and all is nothing but storage. So you have data in the form of files in the storage, and you have frameworks like Spark to process the data. And we just need to understand how to perform the ETL using tools like Spark, which provides us also a framework, a distributed framework to process the data. Okay, now you have a uniform hardware where all the servers will be similar, and the same hardware will support ODS, EW, ETL, and we will understand those things when we actually get into the developing the pipeline using Spark after Python-based approach. So Python-based approach will simulate this type of thing, and Spark-based approach will actually take care of this, where we have the homogeneous hardware, and as part of one hardware, as part of one ecosystem of tools, we have everything that is required to store huge amounts of data and also to process the data as effectively as we can. And then we have to integrate the data. Typically, for real-time integration, still we might have to use some conventional tools. But for ETL, we typically use frameworks like Spark. So the way it will work is, as part of this big data cluster, we will just create a logical layers. So there is only one big data cluster. In that, there will be logical layers such as ODS, data warehouse, etc. And depending upon the company, they use different terms. So in one of the project I'm working on, the entire cluster is called as data hub. Okay, the ODS layer is called as raw layer, and the EDW layer is called as the normalized layer. And then the layer which actually serve the clients is called as user access layer. In some other client, they call using different terms. They call it as baseline for ODS. They call it as customer staging area for EW. And for reporting purpose, again, they might use different terms depending upon the nature of projects which will be deployed. So the terms might be different, but the concepts are same. The underlying concepts are same. You will try to maintain the golden copy of data even in this infrastructure. You can call it as ODS, or you can term it something else. And then for the instead of using data warehouse, which is a bit legacy term, we might use a bit of different terms specific to that organization, but the underlying concepts are same. Beyond ODS, you might have intermediate tables again to support the ETL, and finally we'll have data marts or facts and dimensions to support your visualization requirements. And also with the big data clusters, we can not only serve the traditional reporting requirements, we can also support something called as customer analytics. I will talk about it some other time. So we need to understand how this big data ecosystem or big data based cluster, which is nothing but an enterprise data store. So we want to get data from all different sources within the enterprise into one centralized location, and we want to use this for different downstream applications, right? So the downstream application need not be the traditional BI reports. It can be data science based applications, or it can be this can actually act as a source for some of the microservices in a microservice architecture, so and so forth. We will get into those details at a later point in time. For now, we'll just keep the scope from the EDW perspective. EDWs are typically used for reporting. Most of the BI tools support the work very well on traditional RDBMS tools. Still, the reporting can be much faster using traditional RDBMS compared to the big data clusters. There are some solutions which can be applied on top of big data clusters, which are termed within as part of the big data ecosystem itself. But still, most of the companies use traditional RDBMSs or data warehouses for the reporting purposes. However, this will have only those tables or facts and dimensions which support the reports. All the underlying tables, like the raw tables or the tables which are relevant from the ODS perspective, all those still go into this big data cluster only. We will only port that data which is relevant for our reporting purposes into this reporting database, and then we can actually connect our reporting tool to that, or we can also connect to our big data clusters also, and we can report off of them also. Both the approaches are used these days, and what technologies are used for these purposes, we'll slowly get in there after we understand and build the pipeline using Python first and then Spark, so and so forth. So this is the legacy. So these are the details with respect to the legacy architecture and the modern architecture with respect to EW or data lake or data hub, whatever term the clients tend to use. Now, that being said, let me actually go back into these slides and see if there is anything else that needs to be covered. So I have covered the relevance of operational data stores. I have covered the data marts, and also I have covered the data warehouse. So now let's actually get into the roadmap for next couple of weeks, especially to build the data pipeline using Python. We'll start with data pipeline using Python. to start building the data pipeline using Python, you need to be familiar with Pandas. Pandas is the most popular library with respect to data processing. In our case, to develop the ETL, we have to process the data, right? And for that, we want to use Pandas. Okay, and you have to learn and you have to start using it. So Python programming is required and Pandas is required. I will take you or walk you through what all areas you should focus on, and then we will take it further. So there is a question from Venkat. Can we say reporting database has only transactional tables? I don't know, Venkat, where the confusion is. Transactional tables are there in our source systems. So if you go back to this picture, the transactional tables will be either in OLTP or closed mainframes typically. Okay, so the reporting database. Okay, now I understand your question. What the reporting database will contain, right? So if you go here, what this reporting database contains. This reporting database contain the facts and dimensions which serve the reports. They are not transactional tables. They are facts and dimensions which serve the reports. What are they? I will explain that. What the big data cluster will contain and what the reporting database will contain, I will just cover that in a moment once I go through the details with respect to the pipeline. I have few slides about those, and probably I will take up that question when I get there. That being said, again, I'm reiterating, please ask all the questions in the Slack so that we have the lineage of the questions and we should be able to document. And also, whoever asks the questions, make sure when I provide the answer, make sure you type that answer and make it available for everyone's reference. Okay, that will help us to accelerate our learning process without skipping some of the important questions. For example, Aditya have asked about S3 and all. As it is a relevant question, but as it is not that important at this time, I have dodged that. But it's a very important question and we should be able to pick up that question. We have to maintain the track of these things. So if you keep it in Slack, I can delegate to one of the student itself, and you can keep track of all these questions, and we will come back to these very important questions whenever it is relevant. Okay, or we can actually go through the questions whenever we reach certain milestone. I can categorize where these questions should be answered, and we should be able to review those questions. So we will consolidate these questions going forward and try to answer almost all the important questions. If it is irrelevant, we will not keep it in the document at all. So that being said, first let me actually walk you through how you can actually pick up these Python skills. I have already shared the details as part of the Slack, but as many people might have joined through YouTube also, for their information, I want to walk them through how they can access that playlist with respect to learning Python. So they can go to the YouTube channel, youtube.com/itversityin. Okay, and then in this there is something called as basics of programming Python. Basics of programming using Python. Okay, you can go to this playlist. You can see that it starts with introduction and then getting started with Python, and then basic programming constructs, all about functions. This is about user-defined function. This is about predefined functions, which means the functions that are already available as part of the core Python programming language. Then I have covered collections and tuples, processing collections using loops. If you are already familiar with some of these things, or if you have explored Python a bit in detail already, I would highly recommend you to go through all about functions, string manipulation functions, all about functions, user-defined functions. Actually, you can skim through this. You don't need to go into all the details, as long as you understand how to develop Lambda functions for certain important APIs such as map, filter, etc. You just skim through it. Actually, I will give access to the material which is used for these demos starting from tomorrow as part of the lab access. And you can just go through the code in the notebook if you're already familiar with Python with respect to this module. Then I would highly recommend you to go through the video, at least if you don't understand when you go through the content with respect to collections and tuples. It is a very important module. And then you also need to understand, or if you want to just improve your programming skills with respect to Python, I would highly recommend you to go through this and develop certain functions to process the data. We'll not be using, so don't try to use that approach as part of our solution. Just to pick up some key programming skills, I would highly recommend you to go through this. But if you are already good at Python, you can skip. You can go to the material and you can decide whether you want to go with it or not. Then you can actually go to this developing and using MapReduce APIs. This I would highly recommend you to go through it completely, even if you're familiar with it. That way you will be able to pick up some of the key skills with respect to how the MapReduce APIs are internally developed and also how they can be used. Then data processing using pandas, the core modules with respect to our skills that are required to build the data pipeline using Python and pandas is nothing but data processing using pandas and then database programming using MySQL. So go through these two things and make sure you understand all the aspects with respect to CRUD operations that can be performed using Python as programming language with a MySQL based library, and also how to process the data. And I have integrated these two also and demonstrated how you can take care of loading the data using pandas data frame. So you should go to this data processing using pandas, database programming using MySQL, and also as part of this database programming best practices, I have covered some very important information. You should go through that also. You can skip data visualization. Data visualization is not important for building the data pipeline, but almost for first 35 to 40 minutes or 1 hour, I have covered a very important aspect with respect to database programming. It is nothing but the best practices. You should go through it. It will actually tell you how frequently you should commit the data and all. And that actually drives the complexity of the implementation for our application. So these are the topics which you should focus on: data processing using pandas. If you are already familiar with Python, then you should focus on data processing using pandas, database programming using MySQL, and the database programming best practices part of this. If you go through it, you will get enough skills that are required to build the pipeline using Python and pandas. However, as part of the database programming, I have demonstrated using MySQL. You should be able to relate to Postgres, and you should be able to start loading the data into the Postgres also. Okay, so I'll come up with the design and I will drive the design. You act as a developer and start implementing as a developer. And I will conduct design review sessions the way that happens as part of the enterprises. And I will walk you through the details with respect to the design. You have to be prepared to come up with questions, and you should ask right questions. And you need to make sure you understand the design, and based on the design you can actually start getting into the implementation. While we do those design review sessions and all, in parallel you can pick up the key Python skills and be ready to kickstart the development very soon. Okay, so that's about the skills required to actually build the pipeline using Python and pandas. So first we need to take care of setting up development environment. I'm just giving you high-level details here, and we have already taken care of few things, right? We have made sure Docker is installed on GCP if you don't have enough capacity on your machine to support multiple Docker containers. And also we have created a MySQL transactional database using Docker. MySQL for transactional databases. Actually, make sure we have installed Docker, and then we have made sure MySQL is set up using Docker. Create, instead of saying that, set up MySQL using Docker. MySQL database server using Docker. MySQL is a multi-tenant database server. We can have multiple databases, and one of the database which we'll be creating is nothing but retail database. with tables and data provided as part of MySQL database server using Docker. It is nothing but MySQL underscore retail. So the container name on which MySQL is set up, we named it as MySQL underscore retail. And as part of the MySQL underscore retail container, we created the retail database with the tables and data provided. So these steps are already taken care earlier. Also, I have shown how to create a Postgres. So yeah, let me actually rephrase it a bit here. Setup Postgres database server. Postgres is also a multi-tenant database. That's why I'm using the term called as database server using Docker. It is primarily for the data warehouse. And we will name it as PG retail underscore DW. So that is the name of the container. As part of that container, we will create a data warehouse database, and then we will take it further. Okay, I will come up with a name and I will walk you through how it should be. Then I will just give the details about what all fields the facts and dimensions should have as part of the design review. You have to come up with the create table statements for Postgres, and you should be creating tables manually. With respect to development process, we'll be using something called as PyCharm Community Edition. So I will walk you through how to set it up and also how to set a project and integrate with GitHub for versioning of your code very soon. Probably next week on Monday or Tuesday, I will walk you through this process about setting up PyCharm and also setting up project and integrate with GitHub. Okay, so some of the items are pending, but to consider our development environment setup is complete, we have to take care of these things. Due to the resource constraints, some of you might have the Docker containers for MySQL database server and Postgres database server as part of the GCP, but PyCharm should be there as part of your system itself, as part of your Windows or Mac. You should not be having PyCharm as part of the GCP server. It is not practical to connect to PyCharm. Leveraging a remote desktop, it might slow down a bit, and hence I don't recommend. Make sure you set up PyCharm locally itself. Then I will actually walk you through some of the key features with respect to PyCharm to take care of the development tasks. Now, what are the requirements which we'll be designing our solutions for, and also come up with the implementation? These are the requirements which we want to cover, which I have covered yesterday also: daily revenue, monthly revenue, daily product revenue, monthly product revenue, daily category revenue, monthly category revenue, daily department revenue, monthly department revenue. These, when it comes to BI layer, these can be served using multiple dashboards. Okay, they might not be part of one single dashboard. Okay, and the users for the different dashboards and reports might be at different level. For example, department wise dashboards might the targeted users can be the department heads. Within department there will be categories. Typically in the organization, departments heads will be VPs. Okay, and the VPs of each department might be reporting to COO, Chief Operations Officer. COO is the one who will be monitoring the operations of all the departments. And the VP of respective department will be reporting to COO. So COO might be interested in department-wise performance, so that he can work with the respective VP to improve the business of that particular department, right? And the key stakeholder for department-wise performance might be COO. And when it comes to the category, in each department there are multiple categories, and the VP of the department might want to see periodic reports related to category, and also at the product level, right? So probably we might want to have a separate dashboard for category performance, separate dashboard for product performance, and then separate dashboard for department performance. It all driven by the requirements. We will not be developing the reports based off of this data. We'll just run queries. And if you want, you can connect Tableau and see some visualization aspects of it. But more than that, we'll try to come up with a design for these requirements, and then we'll get into the implementation. What are the facts and dimensions that should be created to support all these reports and dashboards associated with it? All we need is date ID, product ID, revenue as part of the fact. And then as part of the dimension, we need product ID, product name, category name, department name. If you go with star schema, where we have only one dimension for the entire product catalog. And the other dimension should be date dimension. And these are the standard naming conventions which we follow. In some cases, we say F underscore, or we give the table name then underscore F for fact, D underscore or table name underscore D. In some cases, we use fact and dim like this. So each organization have different types of standards. In our case, we are using this standard. And if you look at this, even though the report requirements only talks about revenue, it might make sense to take care of the details related to total order count, the orders which are considered to be revenue generating orders, where the order status is completed or closed. And that's what is used to actually compute the revenue. And we want to get that count also. So I want to take care of that also. So these are beyond the scope of the requirement, but typically we will identify all these related use cases working with not we as a developer, but the business analyst and business will work closely together and try to come up with much broader report or dashboard requirements. To begin with, the reports might have only the revenue related reports and dashboards, but in future, if they want to compute the average revenue, right? For average revenue, we want to get the total revenue divided by revenue order count. We already have this data, and it's just an effort from the BA side to add that additional KPI and generate the report or dashboard, right? So this data model can serve more reports and dashboards than what we have captured already. And onboarding those new KPIs will be pretty straightforward if we think through all the relevant KPIs and start building the solution for it. And who will be doing it? It will be typically done by data architect or business analyst working closely with the business. Sometimes the data warehouse architect might provide some inputs based upon his past experience, but the ultimate decision makers are not the developers or the data warehouse architect or technical architect for the project, but the business analyst or data architect. They will be coordinating with the business, and business will be making the final decision. And based on that, we have to come up with the complete design and implementation plan, and then we have to take it further. So from our perspective, we will be creating facts and dimensions like this, not immediately, but once we have everything ready, once you gain enough Python skills, then we will get into these details. Whenever you say, so make sure you follow those Python related videos and make sure that you start acknowledging that you are ready, that I have already covered pandas, JDBC, etc. So that I keep track of the folks who are already proficient with Python. And once I have a handful of them, I will conduct a session. Those who are a bit behind can catch up and take care of it. Those who already are familiar with, they should be able to take it to the next level and start developing the code. In case if you are already familiar with it, don't get into the implementation directly. You can come up with a design. I can review the design and I can give the feedback. If the design is as per the expectations because you have the past experience, you can go ahead and take care of the implementation. You just come up with a few high-level bullet points as part of the Slack chat and get my approval, and you can start implementing it if you are already familiar with. I will, and also we will do regular review so that you don't need to waste your time in rework. Okay, we have to leverage our time a bit more effectively. So that's about it for today. I just set the roadmap of where we are going to be there in next couple of weeks on top of some of the additional concepts as continuation for the yesterday's session. And if you have any questions, you can ask those questions now. Unmute yourself, you can ask. or you can also ask the questions as part of the Slack, and I will try to answer those. So Manas is asking, sir, is there a way you can show us some examples in parallel? Because of so many processes and new terms, it is becoming confusing to follow along. That's what, once you start implementing those things, you will understand. Don't don't widen your horizon and get more confused. Okay, stick to this example only and focus on the building data pipeline using Python and pandas. Okay, after after going through all this effort, I'll give you the design. Okay, even if you could not follow all these terms, you make sure that you implement the data pipeline. That is more important than anything else. Implementing the data pipelines using Python and pandas is more important for you to than understanding all the data warehousing concepts completely. However, as I have covered some of the key concepts, now when I say fact as part of the design, you will be able to relate at least, and you should be able to think in a right direction. So at the time you can start asking the questions whether you are going in right direction or not, and I will cover. Okay, so don't break too much, don't break your head too much about all these terms. You might have to watch these videos multiple times to digest some of these key concepts. As long as you understand the actual meaning of these terms, fact, dimension, etc., you will be able to build the knack of connecting all these things, and at some point or the other it will start making sense. It might not make sense immediately, but at some point or the other it will start making sense. Okay, but we should not stuck in that by having lack of confidence, saying that, oh, I do not understand the dimension, I do not understand the fact, I want to explore further, I want to read. And if you get there, you will be in loops, you will never make any progress. Even if few things are chaotic, don't break your head at this time. You can come back to this at a later point in time, and then once you implement pipelines, and once you go through these terms multiple times, if you come back to this video will, or yesterday video and today's video, these videos will start making sense to you. Okay, so even when so I will give you some history about how I typically learn, right? These days I don't even read. I'll be able to figure out by myself just by running some key commands. I should be able to reverse engineer most of the tools without taking anyone's help, without even Googling. I will use Google, but even if you throw me a technology, and if you want me to reverse engineer, if there is no material on Google, I still can do that. So how it happened? If you are familiar, I have actually failed in intermediate. Okay, and my intermediate percentage is only 48%. And I started pursuing my graduation. I am not an engineer. I have done my BSc, MPC, Math, Physics, and Chemistry, and I have completed my MCA, Masters in Computer Applications. Even though my intermediate percentage is not good, I am always a brainy kid. I don't want to give you a false perception by glorifying that I built my fortune, even though I'm very poor at academics. I'm always a brainy kid. I don't know my potential as a kid, but my teachers and all always acknowledged that I am a brainy kid. I have good IQ. Okay, but for whatever reasons, I failed in intermediate. And as part of my graduation, I started struggling to understand physics. I used to mug up a lot, and one of my friend used to just skim through at the time of exam, and he used to be very confident, and he used to sleep. I used to read for hours before the exam, even after reading earlier also, but still I'm not able to digest. Then I was skeptic, and I was laughing at him that he was not serious about his exams and all, but his percentages are always good. So I asked him, how come you are taking so light, and how you are getting these decent percentages compared to me? Then he just made one statement: don't read if you don't understand. Okay. Then it struck me, and then I self-introspect, and I felt that his statement is very clear. Then I tend to fix the problem, because of my intermediate background, I'm not able to connect the dots, and I'm not understanding the physics even after reading so many times. And I have good memory power also. I can mug up the whole chapter and reproduce without even a single mistake. I stopped it long time back, but at that time I have that capacity. But still, going to that level is not very trivial, right? Even if you have good memory power. Then what I have done after those exams, I realized that because my intermediate physics is weak, I haven't read physics at all. So my first year physics, I got 16 for the first time, 8 second time, 4 third time. So it's a downtrend. And then fourth time, I think I got 21 is the pass mark. Fourth time, I think I got 18 or something. And fifth time, I got 30 plus. Okay, so it took me 5 attempts to clear my first year physics. And actually, I performed worse compared to the fourth time. In fourth attempt, I got 18, and in fifth attempt, I got 30 plus. Probably the reviewer just gave me the marks. And even those 16, 8, 4 are due to the logbook. As part of the intermediate exams in AP and Telangana, we get the logbooks while taking the physics exam. We can review that and we can answer. So I used to fill some blanks using the logbook. So some of the marks are due to the logbook. I don't even know anything about physics. Then I realized because of that, I'm struggling with physics. Then I started reading from 8th standard physics. Then I went to 9th standard, 10th standard, intermediate, whatever is relevant for the degree. And I built some level of confidence in understanding physics, and I stopped mugging up, and I started giving the exams a bit more confidence. Degree I passed in first attempt. I got a decent rank in MCA entrance, and I completed my MCA. And once I am done with my MCA, okay, I felt obsessed with RDBMS concepts for whatever reason. Even though my professor might not be very effective in teaching, still I liked the RDBMS. I liked SQL. I started building some obsession towards it. And then once I start searching for the jobs, right, it was not a smooth journey. It took me 45 interviews to get my first job. Okay. And but I never got disappointed. In many cases, I went till the final round, and HR don't want to select me because of my backlogs. In India, we have this tendency of checking the percentages starting from 10th, inter, degree, MCA, so on and so forth, right? And now in some of the schools, they are even reviewing the parents' credentials, not only the kids' background, right? So that's how in India the situation in India was. And at that time I was struggling to crack the interviews. Then when it comes to picking up technologies like Oracle, right, I just read through the book end to end. As part of the first read, so to begin with, already I have decent knowledge about RDBMS because I took it a bit seriously as part of MCA. So Oracle started making sense to me. Already I was at 10% or 15% when I started learning Oracle. And then once I read the book end to end, there are so many things which are new to me. Like there is something called as SQL Plus, which is nothing but a client-based tool, which is almost like a Unix terminal. It's a terminal-based tool. It's not like SQL Workbench. So I heard about SQL Plus for the first time. I don't know how to use it, but at least I know the term and I know the purpose of it. Okay, and I started writing some queries. Even though it is not intuitive, or even though I could not digest completely, I still understand few details with respect to SQL Plus. And then I went into the SQL because I am a bit good in RDBMS at that time. Even though I did not run any queries, I think I have ran the queries also. As part of the college also, we got access to Oracle database in the labs, and we ran some queries. And even though I don't know many string manipulation functions and all, once I start reading this Oracle complete reference, I read that Oracle complete reference 4 times completely from first page to the last page. And I think that's the last book which I have read apart from my CFA books. I try to give CFA also in between. But I stopped reading the books because of my eyesight. I cannot read. There is some limitation. I will share the story some other time. Now I don't read any physical books because of my eyes doesn't support. Okay. But at the time I was able to read, and I have read Oracle Complete Reference 4 times. So I have gone through end to end. For the first time, I have gone through end to end for the second time. From the third time, I didn't go through end to end, even though I read from first page to the last page. Whatever are the weaker areas, I just started making sense by the third read and fourth read. And it's a pretty bulky book. I think almost 1,000 or 1,500 page book. And I read it 4 times over a period of 1 month or 45 days. And that's how I am able to build the complete understanding about Oracle database. Even after that, at the time, because by the time I completed that Oracle Complete Reference, I started building some Java skills. And while learning Java, I cracked the job. Even after getting the job, almost for 2 years, I have read 10,000 page content. I have started reverse engineering about JSP, servlets, and all those things. Even though they are not relevant to my job, I used to print a huge number of pages at the office, take home, and start reading those JSP, servlets, internals, and all to build the knack of whatever I am doing today. And today I don't even read a single page, no matter which technology is thrown at me. I will be able to reverse engineer, and I will be able to learn. So that being said, to cut the long story short, the main thing what you should focus is whether you follow completely or not. I will emphasize certain key areas. You focus on those key areas and make sure that you are comfortable in those with those key areas. Once you build the data pipeline, you now at least know Python, pandas, etc. Even though there are some gaps with respect to dimensional modeling. Once you understand those things, if you come back here and once you start visualizing why we are doing this, then automatically you will build the enough capabilities to understanding these skills. Okay, and also once you build the pipelines, you can even go through FAQs about dimensions, facts. You can go to the data warehouse toolkit, and you should be able to see the examples over there. So there are many other sources which you can focus on once you build the data engineering skills first. Data engineering skills doesn't require modeling to begin with. As an entry-level professional, you don't need to be expert in modeling, but at least you should know the terms so that you can be productive from day one. That's why I have covered the concepts, and I try to set the context. Probably now, after yesterday's and today's session, you know ODS, you know EDW, at least from the terms perspective, you know fact, dimension, hierarchy, and all, right? So you are not at zero. And when I do the design review sessions, where based on which you will start developing, you don't need to break your head too much about these terms. Otherwise, if I just say this is the fact and we will be doing ETL, you will not be able to even think about why I am referring to fact. But after going through the series of tasks which we have performed so far, if you follow it closely, if you developed those reports, dashboards, and also attended the yesterday's session and today's session, it will start making sense up to an extent. Still, there will be some chaos, but don't break your head around it. Don't worry too much about other examples and all. Stick to the most relevant skills for our data engineering in the pursuit of learning data engineering. And what are those? What are those tasks which you should focus on? The tasks are nothing but these ones: prototype, visualization using Tableau. And if you look at the approach, right, approach and the tech stack, I did not talk too much about data warehousing concepts here. I spoke about programming using Python, comfortable with SQL and Linux, data engineering, etc. So these are the areas which you should be familiar with. Okay, but you should have some understanding about data warehouse and the concepts related to it, so that you can prepare for the interviews a bit confidently, and also you can be part of the project from the day one. I mean, when I say part of the project, you can be productive in the project from the day one. You might not be 100% productive, but at least 30% or 70% based upon your individual capabilities. Even when I talk about approach, I haven't included the design aspect into it. The reason why I haven't included the design aspect to it is I'll be acting as an architect, and you guys will be acting as developers. To act as developers, you just need to have some basic understanding about the terms. You don't need to worry too much about the concepts at this time. I will make sure that I will articulate the things in a way which you can digest to take care of implementing these things. Okay, some people might get additional value if they have prior experience with these things. Some people at least will be able to build only these things what I have highlighted as part of the approach. Okay, so that is the what I want to say. Those who are feeling confused a bit, don't give up. That's why as part of multiple sessions, I emphasized that don't give up until 6 to 8 weeks, even if it is chaotic. Just follow whatever I am saying. Some sessions might be completely means you might feel lost completely in some of the sessions, but even if you are there for 1.5 hours, even if you are able to digest 1 or 2 words, that is more than enough. So after my after failing in intermediate, after pursuing degree and MCA, right, I used to carry my desktop. At the time, I used to have a desktop. If I have to stay in my relative's house or my sister's house for a few days, even 2-3 days, I used to carry my desktop along with me. I used to carry few books. I used to carry a desktop, the complete desktop along with me. So wherever I go, I used to travel between my hometown and Hyderabad. I used to go to my sister's home. I used to carry this desktop. And also I used to carry at least a book or even a single page whenever I travel for short trips. When after completing my MCA, I might not read at all, but if there is a doubt in my mind, I just want to refer that and clarify that doubt immediately. That's how I used to build the skills, and that's why I am where I am today. So that being said, to answer your question, don't worry too much if you are getting confused. You create a cheat sheet. Make sure that you maintain not the cheat sheet, but you can actually create Excel and start putting all these terms into an Excel in different categories. Okay, and then you can say something is absolutely clear to you, something is not clear to you at all. You can actually highlight a few things as not relevant at all. If few things are not relevant, you can highlight not relevant at all. Then you can actually review the spreadsheet by filtering on whatever should be reviewed again, and you should be able to start building, start closing those gaps. Okay, so that being said, sorry to take too much of time to answer this very important question. I just want to address the concern of people getting lost or confused, just to motivate. So we'll stay in touch. I think there are no more questions. We'll wrap up, and we will continue in follow-up sessions. I will come up with the agenda for tomorrow and day after tomorrow shortly. I will start giving access to those who are consistently attending these sessions. And then I will also walk you through with the material, which is part of those labs. Once I give access to you, whatever I have highlighted with respect to basics of programming using Python, I will be sharing all the material with you as well as part of the lab. And I will also walk you through how to access that material so that you can accelerate your learning process with respect to the Python. That being said, let's stay in touch. And for now, let's wrap up, and we'll continue as part of these sessions going forward. Bye.